Hello. In this video I want to show you how we can graph a trig function and show you how we can graph it by first graphing sine and cosine. I'd like to consider the graph of y equals the tangent of 1/2 x plus 2 pi thirds. Now, we remember that the tangent is the sine divided by the cosine. So what I need to do will be to graph the sine function and graph the cosine function, and then use those two functions to graph the tangent. Now, remember, if I graph the sine, I've got the cosecant because they're reciprocals. If I graph the secant, or rather the cosine, I have the secant because they're reciprocals. And if I graph the sine and the cosine, I can then graph either the tangent, which is sine divided by cosine, or I could graph the cotangent, which is cosine divided by sine. Now, to do this, I need to do three things, basically. I need to find where the graph starts and where the graph finishes, where it starts and where it finishes. Using that, I find its period. Then taking that period and dividing by 4, I find the key quadrantal points to sketch a period of the curve. So here we go. Now remember, this function will start its cycle. I'm thinking sine and cosine. It starts when the angle is 0, when 1/2 x plus 2 pi thirds is equal to 0. I'm going to solve for x. So 1/2 x is negative 2 pi thirds. We'll multiply both sides by 2. And when I do, x is negative 4 pi thirds. So this is where this function is starting its cycle. And it will finish when this angle, 1/2 x plus 2 pi thirds, is equal to 2 pi. So once again, now I need to solve again for x. So 1/2 x will equal 2 pi minus 2 pi thirds. Well, 2 pi would be 6 pi thirds, which would give me 4 pi thirds. So multiplying by 2, x will be 8 pi thirds when my graph completes its cycle. Alrighty, so the period of this curve is from negative 4 pi thirds to 8 pi thirds. So let's take a look at that increment from negative 4 pi thirds to 8 pi thirds is a distance or a period of 12 pi thirds, 12 pi thirds, or 4 pi. And I'm going to divide that by 4 because I need those increments, you see. And I divide that by 4, each increment is pi. All right, each increment is pi. Now notice these are in thirds, so pi is 3 pi thirds. So now I will increment. So from negative 4 pi thirds, I add 3 pi thirds, negative pi thirds. I add 3 pi thirds, I get 2 pi thirds. I add 3 pi thirds, I get 5 pi thirds, and I add 3 pi thirds, and I get 8 pi thirds. So I've got this set up. Alrighty, let's set the graph and sketch our functions. So I'm going to come over here, set up a number line. And I'm starting And if I want to talk in terms of pi thirds, well, I've got negative 4 pi thirds, negative pi thirds, 2 pi thirds, 5 pi thirds, 8 pi thirds. 8 pi thirds, 5 pi thirds, 2 pi thirds, negative pi thirds, and negative 4 pi thirds. The period for sine and cosine would be 1, or rather the amplitude is 1, negative 1. So I'm going to graph first my sine curve. I'll graph the sine curve, and so remember the sine starts at 0, comes up to 1, back to 0, to negative 1, back to 0. So here is the sine function. And now I want to graph the cosine function. Cosine function. Now the cosine, remember, starts up here at 1, comes back to 0, negative 1, back to 0, back to 1. Here's my cosine curve. This is my cosine curve. And now I am ready to use these two to graph the tangent. So the first thing, please remember that the tan of the angle is equal to the sine of the angle divided by the cosine of the angle. So I know that when cosine is 0, tangent has a vertical asymptote. Okay, so here's my cosine, and at negative pi thirds, our tangent will have a vertical asymptote. It will have another one again, and x is 5 pi thirds. And then I want to remember that when the sine is 0, the tangent will be 0. Well, here's my sine curve, and it's 0, so tangent is 0. And here it's 0. Tangent is 0. And here again it's 0, and the tangent is again 0. All right, so here's my asymptote. Sine and cosine are positive. The tangent then has to be positive, and it's going to sweep up towards its asymptote. Now, from negative pi thirds to 2 pi thirds, the sine and the cosine have opposite signs. Therefore, tangent is negative. Here will be 0. And from 2 pi thirds to 5 pi thirds, the sine and the cosine are both negative. That means the tangent will be positive. So I've got another piece of the tangent here like so. And then finally, when I come over here from 5 pi thirds to 8 pi thirds, sine and cosine have opposite signs, and so the tangent will be negative. Here's our tangent curve. And there you go. The graph of the tangent, done easily by first sketching the graph of the sine, the graph of the cosine, finding where the function starts its cycle, where it finishes its cycle, using that to determine the period, and then finding those key increments to mark off those quadrantal quarters of the graph. Graphing sine and cosine, and using what we know about the tangent, we can complete the graph. And such a way we could easily also have graphed the cotangent. We could easily have graphed the secant. We could have graphed the cosecant. Since the secant is 1 over the cosine, since secant is 1 over the cosine, when the cosine is 0, secant is undefined. Since the graph is sitting here, let's go ahead and graph the secant in green. So when the cosine is 0, the secant will be undefined. Now here the cosine is 0, the secant is undefined. Notice cosine is negative, and so from negative pi thirds to 5 pi thirds, the secant is negative, and so this function sitting here like so. Notice that when the cosine is negative 1, so is the secant. And then similarly, here the cosine is positive. Here's the secant function. And similarly here as well. So in y, you have the secant function. So you've got the secant of 1/2 x plus 2 pi thirds. You have the sine of 1/2 x plus 2 pi thirds, the cosine of 1/2 x plus 2 pi thirds, and the tangent of 1/2 x plus 2 pi thirds. I hope you find this helpful. If you have questions, comments, please feel free to leave those comments. I'll try to respond as best I can. If there's a video you'd like to see, please let me know. I'll do my best to make one for you. Remember, I'm doing all of this to help you succeed in math and enjoy math, and it's all for your success. Have a great day.